Hi, welcome to another video on meteorological instrumentation. In this video, we're going to talk about how upper air observations are made, and specifically, we're going to look at radiosondes and dropsondes. So first off, we're going to start with a quick overview of what a radiosonde is. Then we'll work our way through sensors and also errors. A radiosonde is an instrument package that is borne aloft by a free flight balloon. Free flight meaning that there's no line connecting it to the ground. It is released and it carries or travels with the wind. It's expendable, meaning that we don't care where it goes. We're not going to get it back. But it has, of course, a balloon, a parachute to help the sensor package descend rather slowly towards the ground, and then of course the sensor package is at the very end. And what the radiosonde does, it measures the vertical profile of atmospheric variables, and as it travels upward through the atmosphere, it sends down data to a receiving system via radio communications. If the radiosonde also measures wind in some manner, then we call it a ray wind sonde, and there are different ways to do that. They've been measuring upper air atmospheric properties with radiosondes since the 1930s. Before that, they did it with aircraft and also with kites. Today, radiosondes and ray wind sondes are standard operating procedures for all weather services or weather organizations around the world. The instrument package has to be lightweight. These days, typically it's made of styrofoam or very lightweight plastic. Usually weighs anywhere from 90 to 280 grams, depending upon batteries. Of course, batteries have to provide electrical energy for the sensors and also for the transmitter. The transmitter is not very powerful. It's only about 300 milliwatts. But as the sensor goes up, it measures temperature, humidity, measures the pressure, and also it can calculate or figure out the winds. Actually, the sensor is sending down the GPS position, and that is from time to time it sends out the position, and from that you can determine the winds based on how far it's traveled in that period of time. The balloon typically is filled on the ground in a shelter near the National Weather Service, if it's the National Weather Service observations that are being done. The balloons can carry up to 1,000 grams. It depends upon the kind of balloon and what kind of package you want to carry aloft. The balloons are typically white, unlike the multicolored balloons that you see over to the left. Actually, there is people that like to take weather balloons and tie them all together and then do free flight with that. The first person to do that, I think, was Lawn Chair Larry back in the 1980s, and he shut down all of the airspace in the Los Angeles corridor. The balloons are typically filled with either hydrogen or helium. Hydrogen, of course, is cheaper. At most National Weather Services, they use hydrogen. It can be generated right on site. The only real drawback to hydrogen balloons is that hydrogen is explosive. So therefore you see the danger hydrogen, no smoking signs all around the ray wind sonde building. You can also fill the balloons with helium. The problem is helium is very expensive because it's in short supply. You could typically find it in most locations at a supply store. But the nice thing about helium is that it is inert, meaning that it won't explode. The ray wind sondes, since they're expendable, they have to be rather cheap. Cheap is a relative term. When we purchase ray wind sondes packages from GRAW Industries, it costs us $193 per sonde. Now this is in 2018 dollars. Costs approximately $17.50 per balloon, the actual balloon itself, and the parachute is another $17.50, and the helium is $60. So as you can see, the cost of each launch is just under $300. The National Weather Service launches, and also other meteorological entities around the world launch Radiosondes twice a day. Typically they're launched at 11Z and 23 Zulu. That's about an hour before the synoptic observation time of 12Z and 0Z. That's an important consideration. The observations are made a little bit before the synoptic times. Typically it takes anywhere from about 90 to 120 minutes to do a complete Radiosonde launch, and the balloon travels during that period of time all the way up to 100,000 feet. And sometimes if the winds are very strong, you can travel a great distance downwind from where you launched it, up to perhaps maybe 180 statute miles. When weather conditions warrant, if there is severe weather expected, the National Weather Service will launch special balloons or special launches. They'll have special launches. And those are typically made about 18 Zulu during the summertime if there's expected to be a severe weather outbreak. Severe weather meaning tornadic or large thunderstorms. Of course, when the balloon bursts up at 100,000 feet, the Radiosonde package, the sensors starts to descend, and their descent is slowed by a parachute. Here is a map of all of the National Weather Service Radiosonde sites across the United States. There are 92 places where they launch Radiosondes, and they're usually approximately about 200 miles apart from each other. Worldwide, there are about 1,300 Radiosonde stations. You can say, of course, that most of them are concentrated or higher density across land masses. Across the oceans, there's not a lot of information, not a lot of Radiosonde sites. So that would be nice to have more information there, but aircraft can supplement that. The information that we get from the Radiosondes is plotted on a thermodynamic diagram. Here in the United States, we use a skew-T log P, where we plot temperature and dew point. So that's a quick overview of Radiosondes. Thanks for joining this video.